Hi friends, welcome to our channel. Let's have a look at a newly appeared problem. Select key disjoint special substrings. This problem is very interesting, and in this video we're going to explain a solution based on dynamical programming in general. So here let me, the overall is dynamic programming, and in between we need to use data structures. Mainly dictionary. So here let's first quickly look at the problem statement. So given a string s of length n and an integer k, so we want to determine whether it's possible to select k disjoint special strings. So below is the definition of special substrings. So here any character present inside the substring shouldn't appear outside in its in the whole string, and the substring is not the entire string, right? So notice that all the key substrings must be disjoint, meaning that they cannot overlap. So the return would be a boolean. So if you look at example 1, so actually this returns true. But here for sure you cannot start from A, because if you start from A, you need to up to extend to the last appearance of A. And in between, this B also appeared, and the last appear is the end, so it will be the whole string. This is not right. So here in the explanation, the two selected special strings are CD and EF, right? CD and the EF. So this is actually some sort of special, because both C and D and E and F are unique characters in this example. So you can also look at example 3, a special case. When k equals 0, for sure it's possible, right? And then the second one is k equals 3. It's impossible. You cannot start from C, right? If you start from C, it will be the whole string. So you can start from D, so you get 1. Or you cannot. If you start from D, so you get this. D, E, F, D, this at least, right? And then you cannot have 3. So you can have a E, so this is a unique letter actually. You can also have F, right? So this is a 2 in total. So that's why we return false in this example. So here is the constraint. N can be very large, and also S can be, the length can be very large. We need to take temp complexity into consideration. And the S consists only of lowercase English letters. So this is important, because the total lowercase English letters are 26, right? So this is a good thing for us. So with that said, let's look at the coding. So when we do the coding, actually in this video, I'm going to present one version, and then maybe in a later video, I'm going to present another solution. So here we need to know, because for each special string, we need to contain all the unique letters. So for example, here A, and this is the last, right? So we need to have the starts and ends of the letters. So let's first get this information, right? Get start and end of unique letters, of each unique letters. So so for this, actually we can use dictionary, right? So we have first, we can have end, so it's all dictionaries, right? So then basically for I character in enumerate S. So if C not in first, so if C not set yet, in other words, the first time we see this character C, so first C will be I. So for the end, we keep updated. So and then after we finish the loop, the end will be the last occurrence of the character. So this is the one. I don't think we need to print out, because this is very straightforward. So next, so for each letter, the start and the end will have form a interval, and all the characters. So for given the character C, let's see, this is the interval, start of C and end of C. This is a closed interval, and all the characters corresponding to indices in between must be within this one, if they were actually this two form a end, two ends of the interval. Otherwise, we need to expand. For example, there's a character in between, but its end is larger than c, so we need to reset the end. Or if it's smaller than the start, we need to reset the start to make it the smaller one. So that's the logic. So what we want to do is to expand first and end of each interval. Actually each interval. Actually for each character, right? So because all the states within first or end. It's actually at most, 26 characters, unique characters. But let's first finish this. So for C in first, right? So we have we have an end, start, end. It will be first C and end C, right? And then basically for character corresponding to those indices, right? So for I in range start, so actually we can write start start from 1 or start plus 1, but let's write it like this. We cannot use end, I guess. Let's use S and E. So so notice that this does not include the E because the end will be this C, right? And the first, yeah, actually you can here write S plus 1. Let's just write S, that does not matter. So then we have the character. The character will be SI, right? So then how to reset this first? It will be the mean of the original state and the first of M, right? Because this M is within this range, within this S and E. So if all the characters in between should be included from the end to the begin to end. That's why we set first to be like this. And the end will also reset to be max of end C and end M. Actually, you can write S and E, right? So that's it. So next, we are going to use DP to find the maximum number of intervals. This interval is corresponding to, because it's a consecutive list of strings, indices is corresponding to the strings. So for here, let me introduce this length, this S, right? So here I'm going to initialize a DP table. So 0 for this dummy index in. So here I'm writing n plus 1 because here I want to use the interpretation dpi is the maximal number of valid substrings up to, so using this one, using S up to this I. So you can understand interpret I as the length, right? So here is not the index. So now, so because when I is 0, so up to I is empty up to 0. So it's actually before, right? Before, ending before I. So ending before 0 is empty. So the initialization should be 0. That's actually valid. So now let's iterate for I, C in enumerate S. So what we want to do is if I use ending at the current letter, so if I can have more intervals. So first, dp I plus 1, it's at most, at least this this amount. So the thing is to check if at current indices, current index, or at current using if using current character, we can build more substrings, valid substrings. So the logic is like this. So first, if the end of the character end, so this one end of C. So if it's larger than I, by no means we can get a new interval, right? So it only will be possible that it will be I, because end C is at least I, right? So this is the one consideration. And also it cannot be the whole string, right? It means that what's the whole string? The whole string means that if first C is 0 and the current index is n-1. So we don't want this situation. So add not this one, right? So in this case, so ending at I, we can add one more disjoint substring possibly. So the check condition will be this, dpi plus 1 at this one. So because here we are at index I, the length will be I minus 1, right? That's why I said you can interpret here I as the length. So it would be at least the previous state, right? And so because we can have one interval, then check dp start C, or first C, right? Let me see what I use. I use first, right? Right. Why we can do this? This means that from first C up to this index I, so this is a new interval. Then we want to check right before the index corresponding to sub C, to first C, how many this valid substrings we can have, right? So that's the main logic. So afterwards, we just need to return so dp -1 if this is greater than or equal to k, right? So that's all for this coding, this version of solution. Let me first do a quick check. So integer object is not scribable, so s, oh, I see here. So it's not also good to use s. So what do we do? So let me change this one to be first C and end C, and then we just delete this one, right? So then we do slicing to get the character. So now let's run. Yeah, it passes the 3 cases. Now let's do a submit. Yeah, it passes all the cases, but for better understanding, let me do some prints. So here, actually, we can print out the first, right? And also we can print out the end. Let's see. So we can look at the examples. For example, for this A, the start will be 0, and the end will be none, right? Let's see if this is the case. So this A is 0, and let's in total length is, say, 5 plus 5 is none, 10. So last index will be none. This A corresponds to 8. You get this one. B, so it's 1, and then the last will be none, right? So to speak. And E and F are unique characters, so their start and end are the same, both are 6 and 7 respectively. So this is the one print. And also you can get this data information after we do the reset, right? So you can print out this C. I see F. Let's see, not C. I guess still first and end, right? So let's copy here. So this is after you do the expansion, right? So if you start from A, So then the interval will be from 0 and up to none, right? So this is the start and end. But if you start from B, the end will also be none, right? 0 and none. If you start from C, right? So the character just can be just a 2 itself. If you start from D, right? So D is also, itself, right? And then if you start from E or F, it can be also themselves. So in this regard, actually, at least 4 actually we get, right? Both C is unique here. D is also unique, right? So, and E, F are unique. So CD contains the letter C which do not appear. Yeah. So this is the one. You can also see example 2, right? So example 2, if you start from C, you end at 5. This cannot be true because it's a whole string. But if you start from D, you end at 4. So you have this this part. Right? But this just contribute 1. And then you cannot have C. This is not possible. And then if you start from E, you end at E. And then you start from F, you end at F. So you have 2, right? So less than 3. So let's also look at the last one. Nothing to look because K is 0. But it's good to know if you start from A, you need to have the whole string because there's a E in between A, extend to the end. So similarly, you start from B. So if you start from B, you need to add this B. Because it contains E, you need to have this E. And because it contains A, you need to extend to A, right? So it's a whole string. And also similar, if you want to start from E, right? So you need to contain these 4 letters. But A is here, so you need to start from 0. So that analysis actually is a translation of the code here. That's what we were doing, right? So as I mentioned here, you can actually do this. This is also right because first already said. You can see avoid some repetitions at the beginning, but it's still the same thing. And here, and you can also, if you like, you print out the DP tables during the process. So let's see. Print F. So this is I, and this is DP I. Right? Let's see. So description, right? So so this is the example 3. Always you have DP 0. That's right? Because the whole string is not valid. And now let's look at example 1. So at there you have 0, and 1 you just have 1, and so finally you have 4, right? And for case 2, right, at most you have 4 actually corresponding to E and F, right? So with that said, I guess that's sufficient for digesting this problem and this coding. So overall, it is 3 parts: find the ends and starts and end, and then expand to both sides using the intermediate indices quantified by these 2 ends. And then we do dynamic programming. I guess for this problem, due to the bound of the total number of lower cases, we can consider all the cases. We consider each letter as start and each letter as end. So that is 26 times 26 up to a constant. So that would be our next video. So we're going to explain the other way of doing this problem. And for the time complexity analysis, we are not going to do it here because it's rather straightforward. So with that said, that's it for the current video. Thank you for